Guys, so my videos, they look a lot nicer and clearer on my tablet. When I have them stored on when I have the videos on my tablet and I watch them, they look very nice. Even on 240p, they look very nice. Then I upload it to YouTube, and YouTube's auto compression thing ruins it. Kills it. It kills the quality. It makes it look absolutely horrible. So I'm just letting you guys know, I don't have an absolute piece of shit camera. It's just YouTube's compression that's ruining it. Anyway, enough rants about my camera and how all of you are judging me based off of my camera vision. I took off some relays off of some circuit boards I found. I'm trying not to laugh. And yeah, so relays are a little electric component that are like switches that are turned on using electricity. So, these two terminals here, this one and this one, you put electricity in those, and it goes click, and it turns this terminal and this terminal on. It connects those two. So you connect these two to electricity. You put like a 9-volt battery or something onto them, and it'll connect these other two terminals, like a switch. So it's a switch that turns on with electricity. So you put like a 9-volt or something on there, and it turns it on, but those two terminals can run, it says on it here, 12 amps, 250 volts AC, or 15 amps, 125 volts AC. That's a lot of electricity. These little relays are a switch that turns on an extremely high power with a very low power. So you turn off, say, this entire room using a 9-volt battery. It's pretty neat. That's what relays are. You give them electricity, and they turn on like a switch. And yeah, so I've got 5 of these. Well, I'm about to have 6, but yesterday I had an accident with soldering, and I burnt my finger. And now I can't use that for a bit because, you know, it hurts. So yeah, I will have 6 relays soon. I have 4 of these little ones and 2 bigger ones. They're like 2 of these in one. It's like they've still got the 2 terminals. You connect the terminals to electricity and they turn on. But they've got 4 switch ones. So it's like turning on 2 switches with a battery. That's what my other ones are like. I'll go grab all of them. I've gotten all my relays. So there's this little one here I showed you. There's 2 more of those. Identical. And here's the 2 big ones. So you connect electricity to those and it turns on. And it connects these 2 wires to each other. And these 2 wires to each other. But it does not connect them this way. So these 2 are separate from each other. But when it's on, it connects these 2 and these 2. So yeah, it's like 2 of these in one. And something interesting I found out with these is they go brrrr when you hook them up to AC current. They make quite a nice buzz. And yeah, they make quite a loud click when you turn them on and off. So when you hook it up to AC current, it makes a nice buzz. Because AC current is constantly switching polarity. It's going on, off, on, opposite polarity, off, on, off, opposite, off, on, off, opposite, like that. And these relays, they turn on no matter what polarity. You can hook up a battery this way and they'll go click and turn on. Or the other way, and it'll still work. So, And since they make a click when they turn on and when they turn off, I'm pretty sure that would make 240 hertz square wave, or maybe 120 hertz square wave. Not too sure. I'm not the best at mental math. I'm using a diode here. First of all, just because it's got that really long wire and it's easy to connect these. And because it's going this way. So the electricity can't come in here and electrocute my fingers. It won't, like, cause damage, but it hurts. That because this is AC current, and when AC current goes in you, since it's constantly switching, it's constantly grounding itself. It's like even though you've got one wire on you, it still hurts. AC is a bit more dangerous. But yeah. These big ones here don't click nearly as much. Very, very much quieter. Ah, yes, English. Yeah, unlike these ones, which are real loud. But yeah, so here's the 6th one that I want. It's right there on this circuit board. On this little PCB. This is out of a remote controlled on-off outlet. Oh my god, excuse me. Where's that remote? There it is. A little outlet down here. This. That's got a relay in it. You can hear it clicking. That clicking is the relay. So, yeah. One of those stopped working. So I disassembled it. I attempted to fix it. I found out it could not be fixed. So instead I just started removing components. I was gonna remove this relay, then it slipped and touched my finger. The soldering iron, I mean. It slipped and touched my finger, and it burnt me. So I couldn't solder anymore because, you know, it hurt to touch stuff. But I did almost get it off, as you can see. Hold on a minute. I got it. So yeah. This is identical to these. These 3 I got off of a heater processor board. And these 2 I got out of an amplifier. And this one I got out of that outlet thingy. I'm guessing this one goes bzzz as well. Hook that up to my AC adapter. For frick's sake. This is being annoying. Okay, there we go. Yes, it goes buzz as well. How many volts is it? These are literally identical. They're the same brand and everything. These 2 are not quite the same brand. This one is Hankook Relay Co. And this one is Takamisawa. It's gotta be Japanese. Yes, that is Japanese. That's Korean. The other one. But yeah, these are some relays I got out of some stuff. They go buzz when you hook them up to AC current. And I'm gonna go get my power supply and my multimeter. Alright. Multimeter. Power supply. Plug that in. And plug the other end in. Get in, please. Come on. There we go. What's up with this power bar, man? It used to stay up here all the time, and now it just won't. I don't get it. Stay up, holy crap. This is really being a piece of crap with me today. Okay. So I'm gonna hook my multimeter. Oh, it's already on ohms mode. That's good. So when this needle goes all the way up here, that means it's a complete, like, wire. There is no resistance. So I'm gonna hook this thing up here just to show you. See? That means it's not, that means there's no resistance. It's just a wire. Alright, now I'm gonna hook up this relay to the power supply. Stop it, diode. There we go. For freak's sake. I don't think you guys are going to see my components box in this video for once. Alright, there, I've hooked up the relay. You can probably hear it clicking, however it's very quiet. God. Everything's being a piece of crap all of a sudden, for frick's sake. My tablet's falling over, this wire's getting in the way, the power bar keeps falling over. Come on! There we go. Come on. Squish that wire on there. There we go. Okay. Alright, finally. So I've got the relay hooked up properly. So the relay's hooked on. The electromagnet wires are hooked up to the power supply, and the switch wires are hooked up to my multimeter. So when I turn this on, as you can see, the multimeter, I turn it off, it's a switch that turns on when you give it power. It's pretty neat. Yeah, there we go. But yes, how these work is there's an electromagnet in there. And when you put electricity in those, it activates the electromagnet. The electromagnet pulls a piece of metal and moves it and makes it touch the two wires together. Well, one of these, this wire here, this terminal, goes through a wire that goes into that metal piece. Then this terminal has got another metal piece coming off of it there, and the electromagnet in there. When it's on, that metal piece for this terminal goes click, and it moves, and it touches the metal piece for this terminal and connects them. So that's how these work. I've got the insides of a relay in my room somewhere. I couldn't find it. But yeah, there's some relays. How they work, and what they do, and what happens if you put them onto AC. And yeah. Goodbye.